Okay, let's see. A rocket burns 5 kilograms of fuel per second. The exhaust gas velocity is 608 meters per second. What is the thrust of the engine? So basically what we're going to do is we're going to figure out the force that we had to exert on that fuel, right? And which is, of course, the opposite of that force is the thrust on the engine, right? So this is legit, right? Okay, so we're going to go force times time is mass delta V. This is our exhaust velocity. That's the mass of fuel we burn. So the velocity of that mass, right? The time it takes to burn that mass and the force exerted on that mass is what it is, right? So 5 in 1 second. So remember that kilograms of fuel, that's per 1 second, right? Okay, the force is, we don't know. And the exhaust velocity is 608, right? So the force, and that's kilograms, right? The force we're exerting is on this fuel, and that's, of course, the equal and opposite force that we have as the thrust of the engine, right? The fuel exerts a force on us, right? So 5 times 608 is 3040. 3040 newtons, right, is the thrust, right? Then it says, what time must it burn to impart an impulse of 1200 newton seconds? Well, we can do that. Let's carve out some space here, right? So force times time is going to be 12,000 newton seconds, right? So 3040 is our thrust, right? Times time, we don't know the time, is going to be 12,000 newton seconds. Okay. So I think it's 12,000 divided by that answer that we just got. And I'm getting 3.947. And then it says, how much fuel will it burn to do this? Well, it's burning 5 kilograms of fuel per second, right? So here, I'll do it over here. So the mass of fuel is just going to be the 5 kilograms per second times how many seconds, right? 3.947. So I'm going to take the number on my calculator and just multiply by 5, because every second that goes by, it burns 5 kilograms. So it's 3.947, it would be 3.947 times 5. I'm getting 19, the mass is 19.7 kilograms, okay?